Hi, third grade mathematicians. Today, I get to teach you our fourth lesson on fractions. During today's lesson, we get to learn something brand new. Let's look at our learning target for today. So by the end of the lesson, you will be able to explain how you know that two fractions are equivalent. And later in the lesson, you will get to use fraction circles to recognize and generate equivalent fractions. Before we get started on this lesson today, please pause your video and make sure that you have scratch paper and a pencil so that you're able to participate in this lesson with me. Please also make sure that you have your fraction folders and vocabulary resources handy. As always, third graders, let's begin by reviewing all of the information you already know about fractions, starting with some key vocabulary. In our previous lessons, you learned that the unit is the whole. The unit is what is divided into equal-sized parts. You also learned that the unit can change. All of these shapes are our unit. We've had units that are this black circle. We've had units that are rectangles. The unit is simply the whole that is divided into equal-sized parts. You also learned something else important. You learned that the unit fraction is the name given to one of the equal-sized parts the unit has been divided into, such as 1/4, 1/6, 1/8, or 1/12. We know that these two fractions represent unit fractions because only one of the equal-sized parts have been shaded or selected. You also know that non-unit fractions are different than unit fractions. A non-unit fraction is a fraction made up of more than one unit fraction. So more than one equal piece is shaded or selected. These two fractions represent non-unit fractions because more than one unit fraction is shaded or selected. Third graders, I would like for you to show what you know. Would you please look at this fraction on my screen? Let's pause and take a moment for you to apply the information you've already learned. Students, is 4/6 a unit or non-unit fraction? Wonderful thinking, third graders. How did you know that 4/6 is a non-unit fraction? Absolutely, because more than one of the equal 6 is selected. A non-unit fraction is made up of more than one unit fraction. Fantastic thinking, third graders. Okay, my friends, we know even more information about fractions, which will help us be successful in recognizing equivalent fractions today. We know that the denominator is the total number of equal parts a unit is broken into. For the denominator, we consider both the shaded and unshaded equal parts. And you guys have learned that the denominator always goes on the bottom of the fraction circle. The denominator for this fraction is 6 because the unit is broken into 6 equal parts. Remember, I considered and counted the shaded and unshaded equal parts. We know that the numerator is different. The numerator is only the shaded or selected parts. Where does the numerator go? Exactly, it always goes on the top of the fraction symbol. For this particular fraction, third graders, we know that 4 equal parts are shaded or selected. And so my numerator is 4. So I know the name of this fraction is 4/6. Okay, I'm going to give you another opportunity to show what you know. Let's take a moment to identify this fraction. What is the name of this fraction? Outstanding thinking, third graders. Yes, The name of this fraction is 3/4. How did you know? Wonderful, yes. You knew that there were 4 equal parts that this unit had been split into. So our denominator, which goes on the bottom, is 4 to represent 4 equal parts, or fourths. You also know that 3 of those equal parts had been shaded or selected. So my numerator is 3. How do we read this fraction, third graders? Fantastic. We would say 3/4. How are the numerator and denominator different? Pause the video and think about that for a second. Yes, they are different because the denominator accounts for all of the equal parts that fit on a unit. But for the numerator, we only count the shaded or selected pieces. Third graders, give yourselves a pat on the back. We are working so hard today. Okay, third graders, let's sit up straight and listen very carefully because this is our most important new learning of the day. Are you focused? Wonderful. So the new fraction vocabulary word that we're learning today is equivalent. Can you say that with me? Equivalent. Fantastic. What word do you hear in the word equivalent? If you said equal, you are right on track. Yes, we hear the word equal in equivalent. Do you guys remember what equal means? Fantastic. Equal means the same in amount, size, or value. I have some equal representations on the screen for you. Let's look at some of them together. Let's look first at this delicious pizza. You will notice that it's split into 4 equal pieces. I know that the size of the slices of pizza are equal because they cover the same amount of space or area. They're the exact same size. Let's look at some of these other representations. Let's look at these trains. So in this equal size group, you see that there are 3 trains, and in this group, there are also 3 trains. To show that 2 amounts are equal or have the same value, we use the equal sign that you've gotten so used to. We know that 1,465 would be equal to 1,465 because the value in each column is the exact same. Here are some other examples of equal values. 45 tenths we know is equal to 450, and 4/4 is equal to what, third graders? Yes, $1. So we use that equal sign to show that these amounts are equal. I also want to tell you that when 2 fractions are equal or cover the exact same amount of space on the unit, they are called equivalent fractions. And something that's really cool is that you also use that equal sign to show that 2 fractions are equivalent. We know our new learning today is all about equivalent fractions, or fractions that cover the exact same amount of space. So 2 fractions are equivalent if they cover the exact same amount of area on a unit. So when fractions are equivalent, they have different numerators and denominators, but they manage to cover the exact same amount of space on the unit. Let's start with 1/2. So this fraction right here represents 1/2. It's covering half of the unit. One of the 2 equal pieces is shaded. Now let's look at 2/4. You'll notice right away that this unit is split into 4 equal parts. But still, it covers half of the unit because 2 of the 4 equal parts are shaded or selected. I know that 1/2 and 2/4 are equivalent fractions because look, they cover the exact same amount of area on a unit. So the units have been split into different amounts of equal sized pieces, but the shaded or selected pieces take up the exact same amount of space, so they are equivalent. Equivalent fractions are two fractions that cover the exact same amount of space. If you need help explaining whether two fractions are equivalent or not, get out your vocabulary resource, and this little helper right here will help you explain whether or not two fractions are equivalent. You guys ready to practice? Wonderful. Okay, so let's apply our new learning, equivalent fractions. I want to remind you that two fractions are equivalent if they cover the same amount of space. Boys and girls, for this page, I want you to watch as I model my thinking, and then on the next slide, you will get to do some of this with me. So make sure you're sitting up straight and you're really focused. Okay, third graders, so I know that this fraction right here represents 2/8 because the unit has been split into 8 equal parts and 2 are shaded and selected. This unit represents 5/8 because the unit has been split into 8 equal parts and 5 of those parts are shaded or selected. So now I'm going to try to use my new learning to determine if 2/8 and 5/8 are equivalent. Do they cover the exact same amount of space on the unit? Well, let's compare them. They're both broken into 8 equal parts, okay? But 2/8 only has 2 of those equal parts shaded or selected. 5/8 has 5 of those equal parts shaded or selected. So I know right away that 5/8 covers much more of the unit. It's a larger fraction. So I know right away that 2/8 and 5/8 are not equivalent. They are not equivalent because they don't cover the same amount of space. 2/8 is less space than 5/8, so they are not equivalent. Let's look at this one. So my two fractions are 3/4 and 9/12. Again, I notice right away that they have different numerators. They also have different denominators. They've been broken into different amounts of equal sized parts. But boys and girls, I notice that the shaded or selected pieces cover the exact same amount of space. So I know right away that these fractions are equivalent. And the reason they are equivalent is because they cover the exact same amount of space. Pause the video, third graders, and tell me, how are equivalent fractions and fractions that are not equivalent, how are they different? Fantastic. Were you able to say that equivalent fractions must cover the exact same amount of space and fractions that are not equivalent do not cover the same amount of area or space? Great listening. Let's do another one, and this one you'll get to do with me. Okay, so I see that for this first fraction pair, the first fraction is 1/3, the second fraction is 2/6. Do they cover the exact same amount of space on the unit? Remember, their numerators and denominators will be different. We're just looking at the amount of space covered. Are 1/3 and 2/6 equivalent fractions? Pause the video. Yes, third graders, great thinking. They are equivalent because look, they cover the exact same amount of space on a unit. Okay, are you guys ready to try one completely on your own? Pause the video and determine whether or not 3/4 and 2/3 are equivalent fractions. Fantastic. They are not equivalent because they don't cover the same amount of space. Do you guys remember what sign we use to show that two fractions are equivalent? We do use the equal sign. Great job, mathematicians. Okay, let's do a couple more, and then you get to practice generating equivalent fractions using your fraction circles. Okay, so as you know, the unit can change. So for this unit, which is a rectangle, are 2/4 and 4/8 equivalent? They are equivalent. Look, third graders, they cover the exact same amount of space on the unit. If I could draw a line, I'm going to, look, they take up the exact same amount of space. That's perfect. They are equivalent. Which column would I put them in? The equivalent column, because they cover the same amount of space, so they are equivalent fractions. Okay, pause the video and determine, do 8/8 and 1/8, do they cover the exact same amount of space on their unit? Absolutely not. They are not equivalent. Give yourselves a pat on the back. Okay, I'm going to have you pause the video and sort both of these. Wonderful. You're correct. 1/8 and 1/6 are not equivalent. 1/6 covers more space on the unit than 1/8. But 1/2 and 2/4 are equivalent. Even though the orientation is slightly different, they both cover half the unit. Thank you for your fantastic listening, third graders. Now you are able to successfully recognize equivalent fractions and explain your thinking. Now you get to complete the second part of our target. Now it is your turn to generate equivalent fractions. So get your fraction folders ready and be ready to learn this. Thank you so much for your fantastic listening.